So welcome, this is Amy, Earhart Alden Associates, Paul, 910 Drones. We've got Lamar, Drone Education Services. Today we're going to be talking about beyond visual line of sight and doing a live demonstration. Before the live demonstration, we're going to touch on Dock, a drone, which everyone's familiar with, the flight control system, and a couple of value add examples. So now here we are. As you can see, safe landing point has been updated. So we are in the flight base, one of many, flight control softwares. So this is the remote operation software that we're going to be able to access as long as we have that stable internet connection and we have our fleet of aircraft.
Let me ask you, is Flightbase specifically designed for this type of unit, or can they go with other types of units that are out there on the market?
Yeah, so Flightbase is just a third-party software. They're integrating with DJI aircraft. They're integrating with Hextronics docking stations, and they are actively, looking and working with other dock manufacturers because it's hard enough to make the hardware. And
Right.
once you have that hardware, how can you then scale it to the masses? And so Flightbase is a software company that is specifically manufacturing software for remote drone piloting.
And today we're flying a DJI drone docking station 2, correct?
DJI Dock 2.
Okay.
And so once we click, as you see here, and I'll let's see, let me do this real quick. And so you can see here, right? This is our fleet. This is our aircraft. If we had 2 docks, we'd have 2. If we had 10 docks, each dock has its own spot in our fleet control panel. So when we
Okay.
click here, we enter that dock. We can see our dock's location. We can see our safe landing point. Our battery percentage. This is all of our good telemetry. Our drone is not turned on right now, so it's gray, it's not green, but our dock is online. So we can see our dock Theodore. It has RTK connectivity. It's seeing 25 satellites. We can tell what power we're pulling from. We're on our main power, not pulling from the battery backup. The dock is closed, and our internal temperature is currently 92 degrees. Our HVAC, our air conditioning system is in a cooling state right now, keeping
Let
that.
me ask you, how do you know that it's on?
Say again.
How do you know it's on?
So the dock we know is on because it's showing up green. This box is green. If it was gray, it would be offline.
Okay. Okay.
Now we also have our geo zone, so our synced. So our geo fence was synced 3 days ago. When the aircraft powers on, it will resync the geo fence. So we will be able to ensure that our drone has all the current flight control parameters loaded into it. Below that, we have our weather information. So we know as pilots, we have to operate our systems in environments that are uh, in line with the manufacturer's recommendation. So every drone we operate has a max wind speed. It tells us if we can operate in rain, in precipitation. And so right
Right.
now, 91.6 degrees outside, we have no rain, and we have about a 3.5 mile per hour wind. And that lines up with what we're seeing here um, in the camera that is mounted to the top of the box. You can see we have blue skies. And when we look at the trees, we can kind of see um, trees are kind of staying still here. So not a very windy day and zero precipitation.
Okay.
Under our weather, we're going to have our latency. So we need to know our network connectivity. So how well is our connectivity between our dock and our computer? And then how strong is the connectivity between our dock and our drone? The drone is not powered on right now. So there is no connection. And then we don't know what our latency is because again, our drone is not powered on. We'll revisit this section once we get this drone powered on. Telemetry is on our left-hand side. On our right-hand side is where we have imagery. So we have the dock camera, and then we will also have the drone camera once it powers on.
Okay.
Central here is our map, right? Our map that's going to display the drone's location in real time. You can see we have the move this here. We have the status of the drone. The drone is standby. It's in an idle state. It's gray. It is not powered on. And then we can initiate either a mission or go to location by selecting the bars down here. And so what we're going to do for the demonstration is we're going to go ahead and we're going to load up a mapping mission. And prior to loading this mapping mission, we're going to get our pretty much like our pre-flight, right? We're going to be able to zoom in. We're going to be able to check that flight path and ensure that the drone is flying and operating in that area that we want it to. And we're going to get an elevation profile view. So we're going to be able to know as a pilot that we're not going to be interfering with any ground obstacles or any terrain.
And this is all within line of sight from your ground station.
Correct. This flight is all being connected today within visual line of sight.
Great.
So once we've reviewed the visual depiction and the elevation profile, we can hit next. Once we hit next, what's very important is just like our Part 107 operations, when we are on site, just like a pilot who's flying an aircraft, you are responsible for completing a pre-flight inspection, right? Running through your pre-flight kind of checklist prior to initiating any operations to ensure that you have the conditions that that are required. And so at this point, do we have the permissions we need to fly? Yes, we have those permissions. If we needed an airspace authorization, if we needed some sort of specific waiver, our latency, we're getting a latency in milliseconds. So this is 105, 57, 48 milliseconds. This is good. If anything showed up red, we would know that it is not fit for flight.
Okay.
Our dock is hitting 7 satellites. So the dock is seeing 7 satellites, and it's hitting 25 of those satellites are RTK. So we're pulling 25 satellites just to the dock itself. We're in a safe location, and we have a healthy status of all components. We can jump to now our environmental checklist. So the temperature is fit for flight. We have no rainfall. The wind speed is within the aircraft's limitations, and our geozones will be synced. So at this point, we can execute by hitting launch. We will then see the drone open up in the box, and this is all going to happen rather quickly. So we initiate launch. You can see the drone at the bottom now starts to state that it has a mission. The path is showing up. And what will happen is the drone is going to power on.
Mm-hmm.
And so we're looking here now at the drone's telemetry box, and we're looking to see that the drone comes online. When this drone comes online, we can now see green. So the box is green and the drone is green. The drone is seeing about 28, 27 satellites, and the box has opened up.
So Theodore's the box and Lincoln is the drone.
Correct.
Okay.
This is all happening quickly. You can see our cockpit view that we jumped to. We're now in the drone, right? We are monitoring the drone. You can see our telemetry. So our drone's elevation, our altitude is 216 feet. You can see the drone is climbing. You can see the drone is climbing, and it is showing us our relative altitude and also our altitude in relation to the ground and the dock.
Now it said 3.2 feet, the drone size, and now I've got the ground and the dock at 5 foot. Is there a reason why that when it's in the box, it's at a lower?
So as the drone moves, the ground is actually moving underneath it. So
Okay.
the drone has GeoTIFF data. The drone,
Where did you get the geo data from?
so this is pulling its data directly from like a Google Maps API.
And that's why the subdivision's basically unbuilt on the map that we're flying.
Correct, correct. Right. It's not pulling as built current, it's pulling from Google Earth. And so as it's telling you how high the drone is above the ground,
Mm-hmm.
is because the ground underneath the drone moves up and down. And the
Okay.
drone is maintaining 300 feet above the dock.
Ah,
Yes, the drone maintains 300 feet above the dock. However, the ground changes in elevation. And so that's why you see on the screen that the ground altitude increases and decreases. It's just like a pilot flying a plane. As a pilot flies a plane over a mountain or a canyon, the ground elevation is actually constantly changing.
okay.
The drone is maintaining one consistent altitude while the ground underneath is actually moving. And so a lot of folks are familiar with these mapping patterns as far as how um,
The
the,
grid pattern.
the grid, that lawnmower, that back and forth.
Yeah.
Uh, but what everyone's used to is having to go out to that site in order to physically put the drone on location. And so how many folks might be going to the same location every week, once a month? You know, how often we revisit that site, and each time, how long does it take you to get to the site? How long does it take you to set up the drone? How long does it take to set up a base station in order to get RTK connectivity? And so by being able to put a dock on location, whether it's a construction site, a utility site, um, an area of high emergency response, you can then run those missions autonomously.
But the docking station has to remain on site to stay with the current with the calibrations for the next operation and the operation after that, correct?
Correct. With the dock too, once you kind of put this dock down and you calibrate it, if you go moving the dock again, you have to recalibrate it. And with the dock one, dock two, that was a time consuming process. However, with DJI's dock three, you are able to move that dock anywhere you want and you press one button on the software and it will calibrate itself instantaneously. So they have now improved their product one step further by making it very mobile.
Now, um, how much do these things weigh?
This dock 2 is 70 pounds. This
Okay.
dock 2 weighs 70 pounds. What is also important is, right, we have a max height. What's the maximum altitude we can operate a drone under Part 107 without a waiver? 400 feet AGL. And so we have programmed this drone to not operate above 400 feet AGL. And so you can see that max altitude showing up on our telemetry. So as an operator, I know that we are 100 feet below, the drone is 100 feet below that maximum authorized altitude
Up 400 feet.
of 400 feet because the drone is 299, right?
Yeah.
Max altitude is about 100 feet.
Right, right.
So
And
we
that can change with the terrain, or is that change? How how does that change when the
so
drone's in flight?
the 400 feet above ground level is always the same.
Okay.
The drone's altitude above ground level will adjust because we don't have the course set to maintain that altitude. And so you can see the ground gets closer or farther away.
Right. Well, here we're about to have something interesting. The no-fly zone.
And here we have our no fly zone.
Looks like you're flying through it.
And so drone is now paused,
Oh, okay.
and drone is now returning to the docking station. And
Can you put it back on its mission?
so we don't want the drone to return to the docking station, so we can pause the drone and we cannot go back into a mission.
So you can't continue the mission from the other side of that no-fly zone?
Not without putting it back in the box. But here's a good example, right? Where we could say, your pilot scheduled a mission and planned a mission without taking into account the no-fly zone. So instead of the drone just continuing to enter a no-fly zone, right? The drone is smart, the drone is intelligent, the drone isn't going to do something that it shouldn't do. So rather than just continue to blow through a no-fly zone, the drone says, hey, I can't continue this mission, right? I need to return back home.
Right.
Now the software, right, should definitely be better tuned to where I was expecting it to just go around it. Remove that. But the one value of the no-fly zone is, say we're first responders and I want the drone to go to that location.
Yes, that's a good point.
Right? I'm here and I want the drone to go north to this location. So I'm going to hit launch. Well, when I hit launch, this drone will recognize that no-fly zone and it will maneuver around it.
So it is maneuvering already around. Okay.
Which, like I said, this is why I was just I didn't expect it to just say, hey, I'm going to go home, because I've ran scenarios like this where it avoids the no-fly zone. Like, that was pretty cool, right?
That is so cool. Yeah.
And so for folks in public safety that are doing drone as a first responder, when you're clicking on a drone and saying, go straight to this location, what if there's a water tower? What if there's an antenna? Right? So it's an important part that when we're setting up and establishing these sorts of operations, that we have to map out all those areas that we do not want to go.
Is the sense and avoid still work on this when it is in the flight with this flight mode? I saw that it buffered for the no-fly zone, but would it, if it was going to hit a tree, would it hit the tree?
See how there's AGL, RTL, ASL?
Yeah. Or what did you call that? You called that RLT? Okay.
Yeah. Relative to the docking station. And so we're
Okay.
flying 300 feet relative to the docking station. That's a short demo flight right there.
When you say short demo flight, I'm thinking what, less than 5 minutes in the air? A couple of minutes in the air?
Yeah.
And, and then fly.
This is what is answering your question. See how the ground, like the ground,
Yeah.
the ground actually changes height during flight.
Okay.
But the altitude of the drone remains consistent relative to the dock. Dock is here, drone stays 300, but the ground constantly changes. So just like a telemetry on a remote, as this drone's flying this mission, you have your battery, your time remaining, right? In the top,
right.
Your battery remaining bar at the top that we're all familiar with. Our telemetry, as far as how high are we? What's the wind speed? What's the latency? How far is this drone from the dock? What's the speed of this drone? What's the vertical speed? The same information that we're used to seeing. However, we're now doing this remotely. And so we're using additional, right? Our softwares for remote piloting have additional ways of giving us situational awareness, whether that's three-dimensional, as you can see here, where we can actually view this drone's flight relative to the ground and its surroundings, or if that's a 2D map, right, showing us the
Right.
location of the drone in relation to the dock, the location of the drone in relation to the surrounding areas. We can monitor the dock location to make sure that, the environmental conditions at our launch and recovery site are still favorable. But jumping into that cockpit, everybody is familiar with seeing this on their remote controller, right? You've got your telemetry, your live video feed, and you have your moving map.
Right.
Just like another drone, a Mavic 3 Enterprise and Matrice 30, we have multiple payloads, zoom camera, thermal camera. Right, there's a zoom camera. You saw some deer footprint walking through these fields.
There you go.
Obviously, flying a zoom camera, right, at in a mapping mission isn't always going to be the greatest, but I mean, look at that detail as this thing goes pretty quick. How many folks have seen that picture before?
Right.
And then you got your thermal. So the drone that we're operating here is going to be that Matrice 3 thermal version, thermal camera, wide angle camera, zoom camera.
Can you give me multiple views next to each other?
So with thermal, yep, we can pop up a side by side.
Yeah, I'll tell you, this view is better, Paul, than putting a zoom and a thermal next to each other because you can't really tell where you are with a zoomed in.
Right. And so we're actively monitoring this aircraft. We can see our mission progress as far as zoom in here. The amount of progress that we've made, about 75% complete in this short demo flight. We've hit 10 of our 12 waypoints. And what's really neat is some of these integrations, we don't have a dock or we do not have a parachute equipped, but should a parachute be mounted to this aircraft, this button would highlight and we would be able to execute a parachute deployment. We also have land and go to safe altitude. And so if I hit that land, right, it's going to consider that as an emergency. So it's going to require me to double confirm it. Are you sure you want this drone to land here? Confirm emergency landing. We're going to cancel that.
Oh, so it would go down there.
Absolutely. You could get this drone to immediately land.
Now, is it landing at a safe speed or is it dropping at like you've got a helicopter headed at it? What is
That's like a good example why you might use a land command is you have a helicopter coming right toward the drone. And if your only safe thing to do is to descend, you could immediately initiate a land. There are instances where, why do you have that parachute? Well, you have that parachute because that is a last case scenario. If the only thing is that drone is going to create a collision hazard, right? Hey, we need to deploy this parachute. We need to get this drone out of the air as quickly as possible. Hey, there's a failure on board this system. How can we get this drone down and clearing the airspace? And a land command, that would be one example. So, hey, your drone's going to possibly cause an incident with an aircraft. It's safer for you to land your drone in a tree than it is to allow it to remain at the altitude it was at. Right? We don't want our drones to have to land in trees, but that's basically like a ditch point, right?
right? At least it's not going to hit somebody or something. Okay, so now we are headed back to landing then.
So now we are heading back to landing. So we're gonna allow this mission to complete. The drone went up, it captured photos, it took the video. What was it that its mission was? And
Huh, I
that
like
drone will
that.
then touch down. The props are going to spin while the dock closes, and it does that in order to close the propellers and prevent them from getting shut inside the system. Just a really neat design feature. And now once that drone's back in the docks, we're connected to the internet, right? And so any pictures, any video that we captured is now going to be accessible via the cloud.
Okay.
So construction, progress monitoring, environmental, um, security, monitoring, all those types of things, landfills, anything where you have regular change and you're trying to monitor it, you can put one of these docks up and have it just run missions. Now you can pull your photos, you can throw them into a drone deploy, a Pix 4D, and you can make your maps, models, and run your agriculture analysis. You can run your progress analysis. You could do all sorts of information now that you have that data collected. In addition to running these autonomous pre-planned missions, the other benefit to a drone in a box is it is ready to rapidly deploy, right? Drone as a first responder, right? Drone as a security mechanism. And so, hey, we just got a call. We need the drone to go to this location. We're not trying to run some autonomous mission. The goal here is to get the drone on location as quickly as possible. So rather than select the mission button, an operator would select GTL, go to location. I can click go to location, and now immediately the drone wants to know what location am I going to? So let's say we want to go to this area right here on this field, right? So once we click that point on the map, you can see it's going to draw, a basic line. In this example, that line's going right through our no-fly zone. Because when you set up your operations, you got to look at your AO, right? Our area of
Mhm.
operation. Where are obstacles? Where are hazards? Water towers, cell towers, tall buildings. Think schools, think places of large public gatherings. Any waiver you see for DFR, BV loss, ops over people, anything, it's going to require that you're transient in nature, and it's always going to require you to avoid places of public gathering. The FAA doesn't want you flying your drone over a high school, right? Right here. This is an area that you don't want drones. If you can jog around this, right? Places of worship, baseball stadiums, these areas need to be mapped out in your flight software because your pilots are not always going to be able to say, "Oh, I need to avoid this. Oh, I need to avoid this." So softwares allow you to identify these areas of high risk. A drone flying over this area, a prison, right? That's high risk. So we have to map these out so that anytime we deploy a drone, we don't have to say, are we doing the right thing? Think about a sectional chart, right? No fly zones, restricted areas, prohibited areas. If your drone operation takes place in that area, you need to go in and you need to map those restricted areas into your, operational parameters. And so
So
while
you would go in and map a no-fly zone around the school?
yes, that would be for any agency like when you're, if we're saying Holly Springs Police Department was going to run a DFR program. One thing that we would ensure that uh now here's the thing. For a public safety agency, you might have to send the drone to the school, right? You may have to send the drone to a response. But for a drone delivery company, for an asset inspection company, you're going to not fly your drones directly over schools. You're not going to fly your drones directly over areas of large public gatherings. Another example would be Ting Park, right? This is not an area where people should just be flying extended beyond visual line of sight. The FAA doesn't want you flying directly over these fields. So putting no fly zones is one way to ensure that your drone is never putting itself in a high risk environment.
Yeah, let me ask you this. Is it easy just to throw a no-fly zone in around that school?
Yeah. So this is a good thing because, right, we're talking safety and compliance, and that's the whole
Right.
thing. It's totally skipped over. So it's not just the flight, right? We want to talk about the safety stuff here. Uh,
Right.
so yeah, so we can go in here and it's just as simple as going to no fly zones, right? The software is designed so we have our safe areas, our no fly areas. So say we wanted to make sure that our pilots who are operating 7 days a week, because pilots are working different shifts. So as a chief pilot, we want to ensure that we have every mechanism in place to ensure that our pilots are staying safe and compliant. So we can add a no-fly zone. We're going to do a polygon. And so we're going to click right here on the map, and that pops up. And we can then grab and see with my enlarged mouse, this becomes very large.
Might have to, might have to go a little bit low. Oh, you got it.
Yeah, and then you can actually see how this is it's actually a high school and a elementary school right next to each other. So this is how we ensure, right, as an operator that our pilots don't have that ability to, you know, deviate. Like
Well, why don't you show us what happens when you've set a flight path through a no-fly zone, like down below with the house.
And so very good. And so what we'll do is we'll go back to our fleet. And one thing I do also want to highlight here is our geofence. So this ties into the no-fly zones, right? We want to geofence and secure our drone and make sure it's in a sandbox that it can't exit. So when you see this green area, that green area is the safe zone. So as I zoom in, what you'll see is the dock is inside of a safe zone. And so to show you how the no-fly zone works, once our chief pilot, once our responsible person programs these in, we can go ahead and you see the same elevation, right? The drone's going to fly the blue line. The ground is the white line. So we're going to be safe the entire flight. We're not going to bust our max altitude. And we can then hit launch.
Okay.
Our same checklist as before, right? The same checklist. Every time we launch this drone, we have to go through our checks. We're going to launch this drone. Well, just like last time, our box is going to open up. We're waiting for our drone to power on because the drone autonomously powers off once it lands back and it gets that charging going. Come back online. Takes a few seconds. Drone will power on.
Well, I noticed that the box was
Yep.
Okay.
Box.
So the box started opening before he was actually connected.
And then within seconds, right, of opening, you've got drone powered on, taking off. And so as that drone climbs, you can see the ground gets further away. Our max altitude gets higher. And drone will initiate flight toward that no-fly zone.
Okay.
However, it's going to recognize in real time that that is a no-fly zone, and it's going to jog around it.
That is. And how fast are we going?
We're currently cruising at 25 miles per hour.
That's so much better than the other day when you were at 10. It was hard to see any progress. All right. So what happens when it gets there?
Once it gets to location, it's just going to stop on location and it's going to hover until it receives its next command. So for a dispatcher, for a remote pilot operating in a public safety arena, you're now on location and you're just using the screen to maneuver and control this aircraft. Anywhere I'm clicking on the screen, I can now rotate this drone and maneuver it. And from a safety standpoint, right, just like if we were operating this vehicle on site, we're watching our battery, right? We're monitoring our telemetry. We're ensuring that we're safe and that we're fit for flight. when we bring up this map, we have ADS-B, but we don't have any aircraft flying in the area. If there was any aircraft in this area broadcasting ADS-B, they would be showing up on this map, giving us real-time situational awareness.
And what would you do if you saw somebody within, 2 miles of you? Would you bring it down?
Would monitor it. It really just depends on their direction of flight, right? What
Okay.
is the direction of flight? Are they on um,
Collision course?
a collision course or a course of incidents? And then what is their altitude relative to the drone, right? How high are they relative to the drone? If they're 2,500 feet and they're flying straight at the drone, you know, we'll just carry on and let them fly right overhead. If they're at 1,000 feet flying directly toward the drone, now we have less, room. So it's identifying the location of the aircraft and determining what risk exists based on the level of separation. Is traffic no factor? Is traffic a factor? And then continue to monitor it.
Okay.
And so if we jump here into this the cockpit view, one thing I like to point out, because they've got this massive construction. They're putting this big park in over here. But we can flip to our zoom camera. And just kind of show off like that ability with just a low level, 7x zoom to be able to kind of come in here and monitor, right?
Yeah.
That's that. Seeing exactly what's going on site. Maybe there was a call, right? There was a call that came in, and now you're looking for that individual that had maybe a red shirt with a, purple hat that was looking suspicious around this construction site.
Right. And this is going to have time signature stamp and everything else.
Sending all this back, because then we have photo, video, and it's all going to the cloud.
Because the one thing I didn't ask you that I think is important is that this thing has to be hardwired. You can't go with a cellular signal. It's just not made for that. So if you were ever out at a construction site, you'd have to have the capability of getting Ethernet, right?
Correct.
Okay.
With most of those like trailers, most job trailers have that internet just sitting there.
There we go.
Yeah, that is really neat to be able to zoom in on that.
Have then people been throwing rocks at it?
Yeah. Dropping. I should fly through there with my FPV drone.
Oh, that would be cool.
Yeah. And then the other thing too is like there's so much going on here that has to do with safety. So I think you just asking questions about, well, how do you know what your battery? How do you know? How do you
That's
keep,
what I mean. Yeah.
what are you looking at right now to make sure, what would you do if this happened?
Hey, and thank you so very much for running this today. I'm really glad we got a chance to do this, and I'm absolutely confident that we're not going to run into a problem of things to talk about to cover an hour. If anything, we're going to go over an hour.
Notice how right here, it's telling me like, ooh, you're close to the ground. And it's saying warning near ground, and it just climbs. Well, now it's actually going into that the low battery landing.
Oh, so it climbed to its safe level before it to come down.
Correct. This is my favorite thing, is when it's landing.
Yeah.
And one very interesting fun fact about this drone right here, you can't really see it, but the battery right there, the battery has locking mechanisms. So once you put the battery in, you lock the battery in place. It's not possible for the battery to wiggle itself loose. And when you're not there, one of the biggest things that the FAA is big on, a part of your pre-flight, right? When you're doing your pre-flight, you need to make sure that the battery is properly installed, right? You need to make sure that the battery is fully seated. Well, if you do 100 flights with this drone and you never get to physically touch it, DJI has designed it so that the only way to take the battery out is you have to physically lift two locks up in the air.
Okay.
No matter how much that drone vibrates in flight and when it lands, it's impossible for the battery to become unseated because it has a special designed locking mechanism. It's like
That's
an,
cool.
it's like in aviation, when you put latches onto compartments, they usually require like a two-step process to unlatch it to make it more secure. And so that's a fun fact about the Matrice 3 and the Matrice 4 dock drones is they have locking mechanisms to prevent the battery from becoming unseated.
That's cool. Hey, is there anything you can do with that under Theodore? It's got the AGL on your map, and it's those things are together. Is there any way you can get rid of that?
It's because when the drone is powered, it's what you're seeing is the drone and the dock are together, and so
Mhm.
their titles are overlapping, and the only way to get that is you have to move the drone. Or
Okay.
as soon as the drone shuts off, it goes away. But that is literally I have to tell flight base that they need to adjust their graphic user interface so that when the drone and the dock are together, that one of them should go above and one should go below.
Right. Yeah. Okay. Because I noticed when you were out on the flight, it looked like it was Chinese down there. I didn't know what that was. And then I saw the parentheses and I was like, ah, that's definitely just some sort of code.
Yeah.
Yeah.
And then even the heading, the blue arrow, like that blue arrow right there tells you what direction the drone is facing.
Yeah.
So,
Did you
all right.
set your landing and takeoff pad to be at exactly 180 or 90 degrees or two? Were you, did you compass set it in a direction? Or
No,
could it be at like 45 degrees, 60 degrees, 90 degrees?
it just happens to be that's the way the box is sitting. So the box is squared to north, south, east, and west. And when the drone's in the box, it's pointed east.
However, it doesn't have to be that way.
No, as you can have it situated in absolutely any direction.
Okay.
Now what I would say is that the camera right here, this is a camera that's facing out. So what they tell you is don't set the drone up so that it faces east or west the way I have it because when the sun rises, the sun will be shining directly into this camera. When the sun sets, if it was facing west. So does that make sense?
Yeah. So you're gonna get a washout.
You would end up potentially with a washout during that time of day when the sun is like like at night, the sun's gonna set right here. And so the
Well,
sun
is it going to affect? Okay.
no,
Would it affect it through the overall flight, or would that overblown video clear up?
it just clears up. The only thing is it's just gonna be tough for you. Like if you were trying to see this
Oh, so it's
camera,
a safety thing.
make sure the orientation of the security camera on the wind speed gauge is not facing direct sunlight.
Okay.
Otherwise, the service life of the product and the camera view may be affected due to environmental factors.
Okay.
So, like if you set the camera up so it's facing direct sunlight, it would be like staring in direct sunlight. So, that is
Right.
the only thing. When you are setting up the drone, the direction is only important to like where the sun will hit that camera.
Okay.
Otherwise, it can face no any there's no requirement.
Right. Listen, you take care. Have a great week, and I will be talking to you soon. All right, Mud?
See you soon, man. Thanks, Lamar.
All right. Take care, man. All right. Bye.